Well, suppose you roll 2 dice. And the question I have is, I'm looking at right now is what is the probability of rolling a sum of 7? So I'm going to do this 2 different ways. First, I'm going to go ahead and find the theoretical probability. Then I'll go ahead and do this by doing a sample of rolls, rolling the dice over and over and over again, and using that to estimate the probability. And we'll see what happens as I increase the sample size. As I roll more and more and more times, see what happens. All right, so first off, let's look at the theoretical probability. The way you find a theoretical probability is, you list all the different possibilities. Then you see how many of those possibilities add up to 7, and take the ratio. So for instance, if I roll 2 dice, well, it could be that my first die was a 1 and then a 1, or maybe my first die was a 1 and my second die was a 2, which adds up to 3. Maybe it was a 1 and 3, and so on and so on. You can do this for a while, but I'm just going to go ahead and cheat and go right to the list. So here are all the possibilities. And if you add them up, there's 6 possibilities in each of these columns. So that would tell me that there are 36 possibilities. And of these 36 possibilities, well, this one right here, 6 plus 1, that adds up to 7. 5 and 2 add up to 7. 4 and 3, 3 and 4, 2 and 5, 1 and 6. Overall, that would be, there's 1, 2, 3, 4, 5, 6 possibilities. So basically, the theoretical probability would be 6 possibilities out of 36, which are roughly 0.17. Okay, so we have our theoretical probability. Now, what if we want to go ahead and try to find this probability by estimating? So to do that, we'll need a pair of dice. So let's bring up a pair of dice. There we go. Let me go ahead and roll. And I end up, 7 right off. So I'll put a little mark here for 7. So right now my probability is, 100%. Right now my probability is 1 out of 1. Let's try again. 3, now my probability is 1 out of 2. Let's try some more. 9, so that goes in the other category. 5, puts in the other. 2. So let's try again. Let's do 10 rolls, so 5 more. 8, 9, 6. Let's see, that's another 7. And let's see here, that's 9, so 1 more, 12. So let's get rid of that part. So if I count this, that means I had twice out of 10 rolls. That was 2 out of 10. So my experimental probability is 0.2, which is pretty close to the actual probability. All right. And, part of that's by chance. It could very easily have gotten a lot higher, a lot lower than that. But now let's see what happens as the sample size increases. So I'm not going to do this the long way, so let's just go ahead and simulate this. And that is, I'll go ahead and tell the computer, right now this is my Fathom program. I'll just go ahead and tell the computer to roll a die. So let's collect the measure. 4. So right now, both my rolls here neither of my rolls were 7. See my third attempt. Okay, here's a 4th. Here, I'm just going to do this a little quicker. Let's do 6 more. So out of 10 rolls, this time I end up with about 40%. Right. Well, let's go ahead and add another 90. So let's do 100 rolls altogether. And you can see the way this is set up. This first column right here gives me my proportion after that many rolls. So after 100 rolls, my proportion is 21%. This graph here kind of shows what's happening to the overall probability as I roll more and more times. This blue bar is the theoretical probability. Now you notice that when my sample sizes were small, there was quite a discrepancy between the experimental probability and the theoretical, but notice as my sample size increases, I'm getting closer and closer to the actual probability. And it's not just this wasn't just by random chance. If I just go ahead and roll another 100, collect 100, a completely different sample, and I see once again, at the very beginning I'm pretty off, but as my sample size increases, I'm getting closer and closer to the blue bar, which means that as my sample size increases, my experimental probabilities are getting closer and closer to the theoretical probabilities. And if I keep increasing, like say this, add another 400, so this is basically simulating, doing 500 rolls. And it goes, look at the graph, and you notice that the dots here, that's the sample probability, the experimental probability, is right on this line, which represents the theoretical. And that's what happens. As the sample size increases, experimental probabilities tend to get more and more accurate.